Please subscribe my YouTube channel and press the bell icon on the YouTube app and never miss another updates from my YouTube channel. Hello friends, so today I'm going to talk about how to integrate Spring Boot with Resilience4j in this example. And before that I'm going to talk about what is a circuit breaker. So before we are going to use the circuit breaker, so what is the problem and how we are going to be resolved with the circuit breaker. So that's what I'm going to discuss in this video. So first of all, like, what is circuit breaker? Okay, so before that, so what the problems that we are facing, like let's say that we have a service. So we have a service, and if a service is calling B service internally, so if B service is down for a particular time, so how we are going to handle that scenario? Okay, so a service is generally calls like other services to retrieve the data, and there is a chance that the downstreams may be down. So the request will keep going to the down service and exhausting network resources and slowing the performances. And the user experience will be bad and unpredictable. So the failure of one service can be potentially cascade to the other services throughout the application. So this is the solution. Okay, so we can use circuit breaker here. So the consumer should be invoke a remote service via proxy that behaves in a similar fashion to an electrical circuit breaker. Okay, so basically, so the circuit breakers will have three states. One is closed and open and half open state. So what is closed states? When everything is normal, so the circuit breaker remains in the closed state and all the calls pass through to the services. So when the number of failures exceeded that failure rate above threshold, so the breaker will be trips and it goes to into the open state. Okay, so in the open state, the circuit breaker returns an error for all calls without executing the function. So after a timeout period, the circuit switches to the half open state, okay, to test if the underlying problem is still exists or not. So if failure rate is above threshold again, so again from half open state to it will goes to the open state. Okay, so again, like here, like the circuit breaker again is tripped. So if it is 6 succeeded in the half open state, the circuit breaker reset back to the closed state, that is normal state. Okay, so then so the circuit breaker remains in the closed state and all the calls pass through the services. So this is how this circuit breaker will work. Okay, so I'm going to explain so one example here. Okay, so here I have one order service. Okay, so this is order controller, guys. So this order controller is internally calling another service, that is item service. Okay, so this is the item service endpoint. So I have started this application to test this, and I am going to show you the item service as well. This is the item service which will have only one endpoint, okay, which is going to return one string here. Okay, so let me hit the order endpoint. So how it's working, because both services are up now. So this is order endpoint. Okay, so I got output as item selected because the item service is up now. Okay, so if the item service is down for a particular time, so let's make it down manually here. So if you hit again, so you will get a error because we are not handling any exception handling and we are not doing anything here. That is the reason we are getting the error here, right? So in that case, so what we can do is we can use our Resilience4j. So we can make use of the circuit breaker here. Okay, so let me open my order service. So this is the order service. Okay, so if you want to work with Spring Boot with Resilience4j, so we need to be add three dependencies here. First of all, we need three dependencies. Okay, so that three dependencies, so this one, so we need an actuator and Resilience4j, and we need AOP. These three dependencies are required if you want to be work with Spring Boot with Resilience4j. And so once you have added that, and after that, so wherever, so you want to be add like fallback mechanism. So if you are calling inside this create order, right, So on the top of the method, so we have to add circuit breaker annotation. Okay, so this circuit breaker annotation and name of the circuit breaker, so I'm going to take order service. Okay, and so fallback method, so I'm going to take as order fallback method. Okay, so this order service, so let's create the constant. So I'm going to take order service. Okay, and after that we have to add one fallback method. So public, so response entity, so I'm going to take string here, and after that, so this fallback method name should be matched with, here in the circuit breaker we have mentioned that fallback method name, right? So this name should be matched here, and after that method signature should be also matched here. Okay, so we don't have any parameter here. Here in the fallback method we will get like one more parameter, that is exception parameter. Okay, and so I'm going to return some response here. If service is down for a particular time, so I'm saying that, because I'm calling item service, right? So item service is down. Okay, so that's it. And after that we have to add an application.aml file few properties related to this resilience4j. Okay, so basically here the resilience4j circuit breaker, and after that instances. So instances in the sense like order service, that we have defined the service name inside the circuit breaker, right? So that name we have to mention here. Okay, and after that register health indicator true. So we have registered this health, so that is the reason we have mentioned this true. And so we went consumer buffer size, so I will explain later this. And after that automatic transition from open state to like half open enable true. Okay, this is going to be convert like open to like half open state. Okay, so if it is reaches like maximum threshold, and after that failure rate threshold, so we have to mention the failure rate threshold here, so that is percentage, so 50 percentage. So basically this configures the failure rate thresholds in percentage. So when the failure rate is equal to greater than the threshold, the circuit breaker transition to open, and so it start like short circuiting calls. Minimum number of calls, minimum number of calls I have mentioned 5 here. So minimum number of calls 5 in the sense how many number of calls that's going to be allowed. So basically like configure the minimum number of calls which are required before the circuit breaker can be calculated the error rate or like slow call rate. So for example minimum number of calls is 5, so then at least 5 calls must be recorded before the failure rate can be calculated. Okay, and so coming to this permitted number of calls in half open state. So if the circuit breaker strips to the half open state, then only 3 calls will be allowed here. And sliding window size, so basically sliding window size, configure the size of the sliding window, so which is used to be record the outcome of calls when the circuit breaker is closed. And so waiting duration in open state, so how much time it has to be wait in open state. And after that sliding window type, so this sliding window type, so we will mention count based. Okay, basically we have like time based and the count based. So configure the type of the sliding window, so which is used to be record the outcome of calls when the circuit breaker is closed. Sliding window can be either be a count based or time based. So if the sliding window is count based, the last sliding window size calls are recorded and aggregated. And after that we have mentioned like management health circuit breakers enabled to. Okay, to check like circuit breakers information, health related information, we have to enable this endpoints here. Okay, you have to add this health related endpoints here. And once you have added here, so you can restart this application. Okay, started guys. So now I'm going to hit the same endpoint. So before I'm going to hit this endpoints, so let's check the item service is down or not. Okay, the item service is down now, so it has to be called the fallback method. So okay, so let's hit this endpoint. So I got the output like item service is down. Okay, and so let me check the health of the circuit breaker, guys. Okay, so this is the endpoint of the health endpoint, so actuator health. So let me hit this endpoint. Okay, so we got the output like this. So how many buffered calls, and so how many failure calls. Okay, what is the state? So state is closed now. Okay, so let me left side. Yeah, okay, so let me hit this 5 times, guys. Second time, third time, and fourth time. See the status. So we have failed calls is 4. Okay, so fifth time I'm going to be hit it. Okay, now let's see this. See now, so the status has been changed. So it is saying that half open. So because like we have mentioned like minimum number of calls is 5, minimum number of allowed calls is 5. So in the failure state, so it has to be allow only 5 calls, and after that it is stripped to the half open state. Okay, and like if you restart again item service, it has to be start this closed state. Okay, and so this is how it will work, guys. And let me restart this service, item service. So item service has been started. So, so permitted number of calls in half open state is 3. Okay, so now, so let me, okay, so let's hit it again because item service is up now. So the first time, how, see here, so only it is showing buffer calls because this time there is no failures because we are getting the output item selected and we don't have any fail calls. And let's hit it 3 times, second time, third time, and check this status. See, now it's tripped into half open to closed state. So closed state in the sense it will allow the all the calls from the item service. Okay, so that's how it will work, guys. So that's it. So I'm going to talk about how to integrate Spring Boot with Resilience4j retry mechanism in this video. So to work with this, basically we need two dependencies. One is Resilience4j dependency, and after that we need a Spring Boot starter AOP dependency. Okay, and so here basically, so I'm calling order service. This order service internally calling item service by using this endpoint. Okay, so in the service based architecture, basically like so services are talking to each other. Okay, if one service is down for a particular time, or like slow responses due to a large number of requests towards that resource, so how we are going to be reattempt. Okay, so again this order service by using this endpoint to call this item service, right? So what we can do is, so we can reattempt automatically again to hit this item service. So by limit the number of times to hit this item service. So how we are going to do that is, so we can provide the information in this application.yaml file. So that is Resilience4j retry instances, and the instance name is order service. This is the service name, and after that max retry attempts. So maximum, so the maximum number of retry attempts we can provide here. So that is 3 times it is going to be retry, and after that wait duration. This wait duration is a fixed wait duration between the retry attempts. So within this 10,000 millisecond, it has to be attempt 3 times. Okay, so I'm going to provide the 11,000 milliseconds. In the 11,000 milliseconds, it is going to be reattempts 3 times. Okay, and after that, so we have to provide, so here retry annotation. So this retry annotation is going to take name here. So I'm going to take order service, and after that I'm going to take fallback method. So this fallback method is going to take fallback, so I'm going to take fallback retry method. So this fallback retry method I'm going to provide here. Okay, so let me write public, so response entity, so it's going to take string. Okay, so this fallback method name I'm going to take here, so it's going to take exception, and so it has to throw some message, right? So I'm going to add that message here. So let's say that I'm going to say item service is down. Okay, so that's it. And so let's start this application and test this. So 1 second guys, so I'm going to add, so attempts equal to 1. So I'm going to resetting the value. So when you reattempt that one, so because I'm just printing the values here, that is the reason I just reset the value. Okay, so it started guys. So let's hit this endpoint and see. So let's check item service up or not. So item service is down. So when we hit this endpoint, it should call fallback method, and so in the meantime it has to be attempt this item service. So here we can see the loggers. Item service call attempt first time, second time, and third time also it has to be attempt, and we should get the output item services down. This fallback method should be called now. Okay, so we got the output item service down. So the next time I'm going to hit this endpoint, so in the meantime I'm going to start this item service manually. Okay, so let's start this and let's make it up this item service. And let's test this. Okay, so here the first time, the second time, so it's going to, yeah, so we got the output item service is called. So this time we got the output from item service as item selected, because we manually make it up this item service, right? So that is the reason we got the output from this item service. Okay, so it has to be get the output like this. Okay, so that's it guys. So hello guys, so today I'm going to talk about bulkhead design pattern in this video. So and after that I'm going to explain so how to integrate Spring Boot with the Resilience4j bulkhead design pattern in this video. So first of all, so what is bulkhead design pattern? Okay, so the bulkhead pattern is a type of application design pattern, okay, that is tolerant of failure. Okay, so in a bulkhead architecture, elements of an application isolated into pools, so that like if one service fails, so the other service will continue to the function. Okay, so this is the bulkhead design pattern. So if you observe here, we have a ship here. The ship is splitted into small multiple compartments using the bulkheads. Okay, the bulkheads are used to be seal a parts of the ship to prevent the entire ship from the sinking in case of a flood. Similarly, uh, a failure should be expected when we design a software, right? So the application should be split into multiple components and the resources should be isolated in a such a way that so that failure of one component is not affecting to the other. So when to use the bulkhead pattern? So apply the bulkhead pattern so whenever you want to be scale a service independent of other services, and so isolate the resources used to be consume a set of backend services. So especially if the application can be provide some level of functionality even when one of the service is not responding. And so apply the bulkhead pattern to fault isolate components of varying the risk or availability requirements, and so protect the application from the cascading failures. So to implement like bulkhead design pattern, so we have different types of frameworks. So that is like the first one is Hystrix and the next one is Resilience4j. But Netflix is recommended to use the Resilience4j instead of Hystrix because Hystrix is in a maintenance mode. So you can use the Resilience4j. So if you want to be use the Resilience4j with the bulkhead, so we have two types are there. So one is semaphore. So in the semaphore approach, so we limit the number of concurrent requests to the service. Okay, so it will reject the incoming request once the limit is hit. So coming to the fixed thread pool bulkhead, so in this approach we isolate the set of thread pool from the system resources, so using only the thread pool for the service. So we also use a waiting queue apart from the thread pool. So if both like thread pool and queues are full, then only the request will be rejected with the bulkhead full exception. Okay, so I'm going to implement these two approaches in practically. So let's open my IDE. So here, so this order service is internally calling so the item service with the help of this endpoint. Okay, so if you want to apply the bulkhead pattern, so you can apply the bulkhead pattern here. Okay, so before that, so in the pom.xml file, so you should be add so these three dependencies. This is Resilience4j dependency, and after that Spring Boot Starter AOB dependency and Spring Boot Starter Activator. So once you added these three dependencies, then you can add so bulkhead pattern here. So that is so bulkhead pattern name, and so this name should be order service, and after that so fallback method name you have to provide here. So that is bulk head fallback. Okay, and so you have to provide this bulkhead method name, and this method name should be matched with this fallback method name. Okay, so in the bulkhead fallback method name, I'm just returning one response, that is order service is full and does not permit the further calls, and I'm just returning one response, http status response, that is too many requests. Okay, and this bulkhead method will have extra argument, that is exception argument. Okay, and after that we have to provide the bulkhead configuration here. So that is Resilience4j bulkhead configurations and instances, and this instance name order service matched with your so this order service instance name. Okay, and after that we have a max wait duration here. So the max wait duration is 5000 milliseconds that I have provided here, and max amount of time a thread should be blocked for when attempting to enter a saturated bulkhead, and max concurrent calls is 5. So max amount of parallel execution allowed by the bulkhead, that is 5 calls, and that's it. And so you can start this application and test this, guys. And one more thing, I am calling concurrently 10 calls here with the help of this end stream. So this order service concurrently I'm calling 10 times. Okay, so to testing this application, and the item service is up here. So here it is going to be written this item selected successfully endpoint. Okay, so let's see what it's going to be written. Okay, we successfully call this item service. Okay, so if you observe here we have 10 calls here. Okay, so it is provided the thread names, and we did not get any exception because if you observe here, so let me minimize this. So here we have provided 5000 milliseconds, right? And in the item service, so I just provided thread.sleep 4000 milliseconds. Okay, so that is the reason it does not throw any exception, bulkhead exception. What if I provide this is 3000 milliseconds? Okay, so this time it should throw exception, guys. Okay, so this time with the 3000 milliseconds it's going to be allowed only 5 calls, and after that, so the other 5 calls it does not allowed, and it should throw this fallback method. Okay, so let's wait for that. See here, so we got 5 calls, and it is saying that order service is full and does not permit the further calls. Okay, and so this is semaphore. And if you want to work with uh, thread pool bulkhead, okay, we have a configuration, guys. So this is the bulkhead configuration. So this is the official page of Resilience4j, so you can get the Resilience4j configuration from here. So I'm going to attach this link in the description, guys. So let's paste here. So this is order service. Okay, and max thread pool size and core thread pool size and queue capacity. So configure the max thread pool size, and this is configures, we have to configure like the core thread pool size and the queue capacity. Okay, so I'm going to restart this application. So until and unless this thread pool size and queue capacity is full, so it won't throw any bulkhead full exception. Okay, so because this time this should not throw any exception. Okay, let's see practically, guys. See, it's calling like successfully this item service without any exception. Okay, because the thread pool size and queue size is not full, that is the reason it does not throw any exception. Okay, so this is how it will work, guys. So if you have any questions, so please let me know in the comment section. Hello guys, so today I'm going to talk about Spring Boot with Resilience4j rate limiter pattern in this video. Okay, so before that I would like to discuss about rate limiter pattern. So what is a rate limiter pattern? Basically, rate limiter pattern help us to make the services as highly available just by limiting the number of calls so that we could process in a specific window. Okay, so if the client exceeded this limit, so further request can either be declined or be processed in later period, or be serviced by allocating a smaller amount of resources, or by providing only best effort guarantees. Okay, and so the rate limiting is specified in terms of, so request per the second, request per the minute, and request per hour, that is like RPC and RPM and RPH. Okay, so what about like so the client side rate limiting and the server side limiting? Okay, there are like two things, that is client side rate limiting. Basically, the client side rate limiting we will use as a Resilience4j rate limiter, and if you're talking about the server side rate limiting, so we can use the Kong API gateway and the response API filter. Okay, so if you're dealing with the server side rate limiting, okay, so these are things requires like caching and the coordination between the multiple server instances, so basically which is not supported by this Resilience4j rate limiter. Okay, so and the next one is like rate limiting versus the throttling. So the difference between the rate limiting and the throttling is, and the rate limiting, basically the rate limiting policy is the limit the number of requests an API accepts within a window of time. Okay, and so after that, so the API will reject the request that exceeded that limit. And so throttling, basically throttling, so the same as rate limiting, but so the throttling policies is queues a request that exceeded the limit for the possible processing in a subsequent window. So the API eventually reject that request if processing cannot occur after a certain number of attempts. So basically these attempts you can configure a delay between the retries as well as the limit number of retries here. Okay, and so if you are integrating Spring Boot with Resilience4j rate limiter, so we have to configure these properties in our application.yaml file. Okay, so basically we have to define the limit for period. So the default value is 50 here. So basically this is 50 request will reach out to the our services within 500 nanoseconds. Okay, so if you want to customize, you can customize here. If you want to define 10 requests, you can define the 10 requests here. And if you define like 5 seconds instead of 5 9 seconds, so within 5 seconds it will reach the 10 um, request to that service. So after that it will reject that requests, and the timeout duration is 5 seconds here. Okay, the default wait time threads waits for the permission. Basically it will take the delay 5 seconds here, set off the threads here. Okay, so let's see practically how it will work, guys. So now, so I'm going to show you like how to achieve this Resilience4j rate limiter in practically. Okay, so to work with this, basically we need these three dependencies in the pom.xml file. So one is like Resilience4j Spring Boot 2, and one more thing is like Spring Boot Starter AOP, and after that Spring Boot Starter Actuator. Okay, so once you have added these dependencies, so you are ready to work with Resilience4j rate limiter. And so I have a sample controller here, so that is order endpoint, so which is internally calling so another endpoint, that is item endpoint. Okay, so let me start this item service as well, guys. Let me open the item service. Okay, so this item endpoint just returning one string, that is item selected successfully. So let me start this. So once it is started, so I'm going to show you the configuration for the rate limiter here. Okay, so here we need to add rate limiter annotation here. So this rate limiter will have a name. Okay, so this name is I'm going to take as order service, and if you want to provide like fallback method, you can provide the fallback method here. Okay, so I'm going to take rate limiter fallback. Okay, and so let me write one method, public so response entity, which is going to return the string here. I'm going to take the same method name here, which is going to return exception as a parameter here. So here I'm going to take order service so does not permit further calls. Okay, so here the HTTP status I'm going to take as too many requests. Okay, so this name should be matched with this fallback method name. Okay, so that's it. So if you are coming to the application.yaml file, so here we need to provide Resilience4j rate limiter configurations. So this order service name should be matched with your this order service name. Okay, this name, and after that, so we have provided like limit for period and limit for refresh period. Okay, so within this 4 seconds it's going to allow only 2 calls through that wrapper. Okay, and so for time being I'm going to take this timeout duration as 0. Okay, and so this is just register health indicator is true and event consumer buffer is 100. Okay, so this is for the health indicator, and we have some management endpoints to see the actuator endpoints. Okay, and that's it, guys. So let me start this application. So application has been started successfully, but now so I want to be hit that service concurrently. Okay, and so basically so if you want to test like load testing, okay, if you want to hit like concurrently the request to that service, so we can use the jmeter. Okay, so I'm going to take the jmeter here, guys. This is the jmeter. You can just download the jmeter from internet, and so here you will find like bin. So inside that bin, so if you are using like linux, or like if you are using like windows, then we will have like jmeter.bat. so if you are using like linux machine, so you can use jmeter.sh file. Okay, so but I'm going to use the mac here, right? So that is the reason I'm choosing this one. So you can just start this. So it's going to take like couple of seconds to start this jmeter, guys. Okay, so once it is started, so I'm going to show you how to configure this jmeter. Okay, so it started, guys. Now so let's click on this test plan. So here you will see like thread users. Okay, so you will find like thread group here. Click on this. So number of threads, so that means like users, number of users, how many threads it's currently hit to that your art service. Okay, so I want to hit 20 threads. Okay, and after that, and so we need sampler http request here. Okay, so this will ask the server name. Okay, basically our endpoint IP name is localhost, right? So I'm going to configure as localhost here, and the port number is 8080, right? And after that our endpoint name is order. That's it. And if you have any parameters in your endpoints, you can just configure key and values as parameters here. Okay, so it's ready, guys. Now so if you want to see the response, right, so how you are going to see the response, right click on this. So you will see the listener here. Just take the listener and we will see this view result tree, right? So click on that. Okay, so you will see the results here. Okay, and so it's ready now. So let me start this. So this is start button, so you can just click on that. So before it's going to start, it's asking to save this. So let's save this. So this jmeter, this group will save with .jmx file. Okay, so I'm going to take resilience underscore rate limit. Okay, let's save this. Okay, so it started, guys. So if you observe here, so we have only 2 requests is successful, and so if you click on this, you will see like what is a thread group name and how much time it is taken. So all those information you can see here, and the response data as well. You can see here the response data is item selected successfully, right? And so if you click on the failure request, so you will see that order service does not permit the further calls as well, right? So this is how this jmeter will work, guys. And so whatever that configuration that we have provided in the application.yaml file, so within the 4 second it is allowing only two calls, right? And so what about the timeout duration? Okay, so the timeout duration, basically if you see here, so the default wait time, a thread waits for the permission. Okay, so if you want to provide like some time here, so basically it will wait that much of time. So I'm going to provide the 10 seconds time. So after the 10 seconds it's going to be get the permission, and again it will attempt to that, okay, that services. So let's see this time. So I'm going to restart this application. Okay, it started, guys. So let me hit again the start button. This time see, so it's waiting like 10 seconds for each and every set of requests. Two requests are hitting parallelly. Okay, so if the time is passed out, so this 10 seconds is passed out, that then we will get that timeout error, that is like other service does not permit further calls like this. Okay, so these times it's allowed only 2 2 4 6 8 calls, right? So because of this timeout durations that we have provided 10 seconds. Okay, so if you increase this again, it will allow like more than 8 calls here. Okay, so this is how it will work, guys. Okay, so this is for the rate limiter. And so if you want to say like so Prometheus, Grafana as well, so we can see that. Okay, so this is Grafana, guys. And so here we will have like dashboards. Okay, so if you click on this dashboards, so let's click on this add new panel. So basically here we need a metrics. Okay, that metrics we have to provide by using Prometheus. Okay, Prometheus will provide like some metrics. Okay, so here if you'll see here, so we will have like a couple of metrics here, right? So that metrics information, so we can customize by using this resilience rate limiter waiting threads and resilience4j rate limit calls total, like this. Okay, so how we will get this resilience4j related metrics is, so what you need to do is you can just open your, so let me show you that, guys. Okay, here, so this is Prometheus, right? So once you install the Prometheus in your system, so you can just open this. So here you will find the prometheus.ml file. So in this ml file, so let me open this, guys. So basically we have to add the job name. Okay, this is the extra portion that I have added here. Okay, so that is Spring's actuator. Sorry, guys. So here we need to add the metrics path, so that is actuator Prometheus. Okay, and so the interval time and the static configs, the target name. So our endpoint is running on localhost 8080, and so actuator Prometheus. So if we hit that enter point, so that endpoint. Okay, so let me hit that endpoint. So localhost 8080 and actuator. Okay, so metrics. See, so the same thing. So let me open my Chrome, guys. So the JSON format you can see in the Chrome. So let me hit the same endpoint. See, you can see the data in formatted way. Okay, so these are the endpoints. Okay, you can see here. So that configuration that we have configured, okay, in the Prometheus. So once you have configured that information, so then so you will see that information in the Prometheus metrics. So otherwise you can't see this, guys. This Resilience4j related metrics you can't see without configuring that job information. Okay, so now, so if you want to see that rate limiter waiting threads information, the Grafana, you can just copy this query and come to this Grafana. You can just paste over here and click on this. Okay, so we'll see the nice graph here. Okay, so how many waiting threads are, so you can see like this. And same thing, so come here and we will have like Resilience4j rate limiter available permissions. You can just copy this. Okay, but paste here and see this. Okay, so this is how like it will work, guys. So that's it. So earlier like so I have discussed about Resilience4j rate limiting. So now I'm going to discuss about time limiting. Okay, so before that, so I would like to discuss about, so what is the time limiter, and so how we are going to configure this Resilience4j with time limiter. Okay, so first of all, like, what is the time limiter? So setting a limit on the amount of times that we are willing to be wait for an operation to complete is called time limiting. And if the operation does not complete within the time that we have specified, so we want to be notified about with the user with a timeout error. Okay, so basically, so this Resilience4j time limiters that we are going to be configured is, so the time limiter can be used to be set the time limits, okay, so on the asynchronous operations that we implemented with the completable feature. Okay, so which was introduced in Java 8. And so basically, so in the real-time application, so if you are like invoking like database services, and if you are not getting after some amount of time, so the user will get frustrated, right? And so this kind of scenarios we will use this time limiter. And so the Resilience4j time limiter configurations we will configure like this. So the timeout duration is so 2 seconds, and after that so we can configure that cancel running future. So if you are going to be configured whether it's a true or false, so whether cancel should be called on the running future. Okay, so this is how you can configure this Resilience4j time limiter configuration. Okay, so let's see practically how we are going to implement this. So to work with this Resilience4j time limiter, basically we need a three dependencies. One is Resilience4j dependency, and after that Spring Boot Starter AOP and Spring Boot Starter Actuator. And once you have added, so I have a controller here. So that controller is order controller. Okay, so it's internally calling, okay, slow service. Okay, so this slow service having slow method. So let me open this slow method. So this is slow method. So I just specified some amount of time that thread has to be wait with the help of thread.sleep here. Okay, I'm just returning one response that is slow service is invoked successfully. And so here, so if you want to be work with like Resilience4j time limiters, you have to use this completable future. Okay, and so we have a different types of methods in this completable future. We have a supply asynchronous method, so I'm going to make use of this asynchronous method here. And after that, so we have to use so time limiter annotations. Within the time limiter annotation we have to specify so name of this. Okay, so basically I'm going to use the order service, and after that so we want to use the fallback method. So I'm going to take as fallback method name as time limit fallback method. Okay, and so after that, so this is the fallback method that I'm going to use. So this name should be matched with this name, guys. So you can just make sure that. And after that, in the application.aml file, so you have to provide so this Resilience4j. So let me, yeah, this Resilience4j time limiter configuration. So that is the instance name is order service, and timeout duration I just provided 2 seconds. And after that, cancel running future. So if you want to be cancel the running future, you can make it as true. So if you don't want to make use, then you can make it false here. Okay, and that's it. You can start this application, and let's see practically how it's going to work, guys. And before that, so let me stop this. And so basically in the slow service I just provided some thread.sleep some information, right? So let me comment this code first. Okay, and let me show the output, and after that let's enable this code. Okay, so it started, guys. So I'm going to make use of so same this jmeter here. Okay, so the endpoint is same. So let me hit it again, and let's see the output here. Okay, so if you are observed here, so we are getting like so timeout error. So if you go to console and if you see here, okay, so the context path through an exception request processing failed, nested exception is so undeclared throwable exception, so with root cause. Okay, so all calls are failed here. Okay, so if you enable this, okay, so if you enable this code, so let me rerun this application. Okay, it started, guys. Let me clear this and let's hit this endpoint this time. So this time I want to see the output. Why it's still failing? Time limit fallback throwable. Okay, I got it. Basically it does not allow this fallback mechanism, guys. We have to specify in the circuit breaker. So let's see this now and restart this application, and you can rerun this application. Okay, so now it started. So let's clear this console and let's hit this again. See this time, so we are able to see some successful calls. Okay, and we are able to see only 5 calls are successful and remaining calls are getting cancelled. Okay, and so if you decrease this thread sleep time, so now if I'm making 1000 milliseconds instead of 2000 milliseconds, so this time I'm expecting more successful calls. Okay, because the thread is waiting only 1000 milliseconds instead of 2000 milliseconds. Okay, so let's see this practically. So in the 2000 milliseconds we are able to see 5 successful calls. Okay, let's clear this, guys, and let's hit it again. See this time, so we are able to see 2 to 4 6 8 10 12 14 calls are successful out of 20, right? So this is how it will work, guys. Okay, so this is how you have to configure the time limit in this application.yaml file. Okay, so okay, if you observe here, so we have like some exceptions. So the application is thrown, so this is time limiter order service recorded a timeout exception, right? So this is how it will throw the time limiter exceptions, guys. Okay, within that time, so if the service is not hit, so then we will get this timeout exception. Okay, so if you observe here, so we have a couple of timeout exceptions. So if it is succeeded, then we will get the output. So if it is not succeeded, then we will get this timeout exception. Okay, so that's it, guys. So if you like this video, so please go ahead and like and my video, and if you haven't subscribed my YouTube channel, so please go ahead and subscribe my YouTube channel. Thanks for watching. Bye, have a good day.